just
You
jumped
were
right in.
You were just jumping all over like, and yes, that's probably gonna get left in because why not? All right, 5, 4, 3, 2, 1. Welcome to Spray Nation, another glorious day here in Chattanooga, Tennessee. We're in studio 494.
Sure enough.
Why not be? Today we're going to get chemical. Let's get chemical.
Yes.
Let me hear your admixtures talk.
All right. That's really weird, but okay.
Look, music in my head, and I promise you there's going to be somebody who I just caught what I just did.
Yeah, oh yeah, there will be.
One person.
Yes.
They'll probably comment, you're an idiot.
It's probably going to be the same guy that sends you all that fan mail that you get.
That's you.
Oh yeah. Well, all right.
And the postman's really asking you to quit since we're right next door to each other, and obviously just walking over to me.
All right, so chemical admixtures in concrete. There are how many different kinds of chemical admixtures, Josh?
Really 5 major classifications of them. That doesn't mean that everything that's considered an admixture fits in those, but there's really 5. And we're talking about a water reducer,
Okay.
accelerators,
Okay.
high range water reducer,
Okay.
all commonly around here known as Super P. And the difference is the percentage of water replacement that they're doing versus
yeah.
water reducer versus high range.
We used to call it monkey piss.
So if part of me wants to go, why do you call it that? And I'm sure that you're going to give me some strange answer, which in case is going to lead to other
Same
questions.
reason we call manufactured crushed limestone sand blue sand.
Well, never mind.
All right.
The North Georgia thing.
Yep. We have
Going
nicknames
back to water reducer accelerators, high range water reducers,
Yes.
corrosion inhibitors,
Yes.
and set retarders / hydration stabilizers.
Okay.
So you, from the ready mix
Yep.
side of things,
Yep.
in your background, let's talk about, let's separate the water reducer and the high range water reducers.
Sure. Your type A water reducers or your normal range water reducers are going to reduce the amount of water that it takes to get a mix to a given slump by around 5% or a little better. And that's important because we know that the addition of water is going to decrease your compressive strength. It's going to decrease your durability as you go up and up on water. That's Abrams' rule or Abrams' law that we've discovered in the early 20th century, the early 1900s.
Pause.
Yep.
Why are we adding extra water? I mean, if we only need X amount in, and it's going to do what it's got to do, why are we having to worry about adding extra water?
Well,
and I know, but
yeah.
the audience might not know.
Yeah, because you want to place the guy in the field that's placing and finishing the concrete
Right.
is going to want to place that concrete in a way that doesn't kill his guys. He's not going to want to place a 3-inch slump concrete if he can get away with it. He's going to want to place a 5 or 6-inch slump concrete
Right.
so that he can work it and make it do what he wants it to do and look how he wants it to look. So if you're not using admixtures to get that extra flowability, then water is readily available on the truck typically.
But if we get from the ease of use of placing concrete,
Yep.
there is also the constructability side of it, limiting your honeycombing, limiting some other things to make it a lot easier. So you get, even if you kept your concrete water and flowability lower, you get some strength, but just in the field you might not get it because of vibration issues and some other things going on. So there's a balance there.
There is.
Of trying to get things placed from the finisher standpoint, but also from structural standpoint.
Yeah, so just because you've got low slump, low water content concrete and it gets great strengths in the lab, your actual in-field use, if you can't place it and you can't avoid the honeycombs and you can't get good coverage around your rebar and all
Right.
those things, you can have some issues. So the water reducers, like I was saying, you got a 5% or so reduction in water when you add a type A or normal range. The high ranges are going to be 12% plus
Right.
typically. So you end up with, you've got a gap now between 5% and 12%. So that's where the mid-ranges come into
Right.
play. It's not really, mid-range it just lies between the normal and the high range.
Well, mid-range actually falls under the water reducing category. Because if you actually look it up, it's 0 to 10%.
Okay.
And then 12% on the high range. So yes, the normal type A and mid-range actually falls into that.
Okay.
There's the 11% missing, which I've yet to figure out where that goes.
Yeah. If you that's
You
a
skip
true-
11.
Yeah, you just got to skip 11. If you ever make a product that gets 11% water reduction, you're just out of luck.
You're just going to skip it. 10 below, 12 up.
So the set retarders are pretty obvious. It slows down the set of the concrete. So if you need more working time, you can use a set retarder or hydration stabilizer to slow that setting process down so that you can finish it without it setting up too quickly on you. The accelerators are going to kick that setting time off. So if you're in the middle of wintertime and with no admixtures in it, your concrete's going to take 12 hours to set.
There's times where you just got logistics of getting the concrete to the job site that you might want that in.
That's
Temperatures during the day or, rush hour traffic, things can happen where it's just, it's not so much the distance necessarily.
Yeah.
Go to some of these big cities, you're not going to move that concrete truck very far, very fast, so you might want them in there as well. So it's not just a placement standpoint.
Great point.
It's, logistics of getting the concrete to the job site in a viable condition to place.
Yep. Great point. And I have known folks in the past who were able to put concrete to sleep, is what we called it when using a hydration stabilizer, for days.
Right.
And then wake it back up to then be placed. So really your imagination is the limit on what you can do. On the the opposite end of the coin, local municipality, when I was in the ready mix business, came to me and asked me to come up with a mix that would accept an asphalt paver on top of it at 4 hours. From the time it left the chute to the time they put a paver on it, they needed it to be as short as 4 hours. And by using some non-chloride accelerators, high dosage, we were able to do that. So you can really adjust the set times based on your chemical admixtures. Things like corrosion inhibitors can help reduce the rebar corrosion, that kind of thing. So there's a lot of different admixtures on the market. I like to say in some of the presentations I do, I'll talk about how if you can imagine what you want concrete to do,
there's an admix out there for
the
it.
chances are there's a chemical admixture that's going to do that for you.
If you got any questions, like, subscribe, hit us up. We love answering questions. Appreciate it. Thank you.
Have a great day.